Chapter 4, Section 2, Patterns and Linear Functions. In a relationship between variables, the dependent variable changes in response to another variable, which we call the independent variable. Examples of independent and dependent variables. Notice on the left column I have independent variables. On the right column I have dependent variables. The first independent variable says the number of hours studied for a test is what it should say. Test didn't get in there. And the dependent variable, or what depends on the number of hours you studied for a test, would be your test score. So the next example, we are given the independent variable, the number of books read in a year. Well, what depends on the number of books read in a year, and there's several different dependent variables that you could come up with, but the dependent variable that, for my example, is your reading level. So it depends the number of books that you read in a year. Your reading level depends on that, because the more practice you have reading, the better reader you become. The next example, the dependent variable is your level of boredom. So what does your level of boredom depend on? Your level of boredom depends on the independent variable, what you are choosing to do. Now, you could come up with several different ones here. Sometimes right now you don't get to choose what you're doing, so your level of boredom could be that you were grounded or that your parents didn't let you go somewhere, and so because of that, now you're bored. But what I said is what you choose to do would be independent, and then your dependent variable would be your level of boredom. So it depends on what you're choosing to do, whether you're bored or not. The last example for independent variable, I have written annual salary. That means how much you get paid in a year. What depends on the amount of money you get paid in a year? What I came up with, and again, there's several different options for your dependent variable. But what I came up with for a dependent variable here is how or where you live, and another example would be if you get to go on vacations or not. So depending on how much money you make, if you're not making very much money, you're probably not going to get to go on vacations because that's extra money. If you're making a lot of money, you're probably going to live in a really nice house and you're probably going to get to go on several vacations. So whatever you get to do, how you live, where you live, and vacations depends on how much money you make. It says values of the independent variable are called inputs, and values of the dependent variable are called outputs. So the independent variable we're going to put into an equation, and whatever result we get will be the output, or the dependent variable. This example says, what is the relationship between the number of vertices in each polygon and the number of isosceles triangles? Remember, vertice means angle. So if you look at the first example, we have a square which has 4 vertices, or 4 angles. If you notice, when we have 4 vertices, we have 4 triangles created. On the polygon, or on the pentagon, which is the next shape, we have 5 vertices and 5 isosceles triangles. And on the next example, the hexagon, we have 6 vertices and we have 6 isosceles triangles. What is the independent variable and what is the dependent variable? Well, a polygon can have, a poly means many, so a polygon can have many vertices. So your independent variable in this case would be the number of vertices, and your dependent variable, or depending on how many vertices you have, that is going to tell you how many isosceles triangles you have. So the number of vertices is equal to the number of isosceles triangles created. Your independent variable would be the number of vertices of the polygon. Your dependent variable would be the number of isosceles triangles formed. So if I asked you how many isosceles triangles would be formed for an octagon, remember octagon has 8 sides and 8 vertices, you could tell me that there were going to be 8 isosceles triangles. The next example says, in the diagram below, what is the relationship between the number and the figure number and the number of squares in the figure? How can it be represented? Well, first thing we need to do is look at the figures that were given. Notice in figure 1, I have 5 squares. In figure 2, I have 9 squares. And then in figure 3, I have 12 squares. I'm sorry, I said that wrong. In figure 3, we have 13 squares. First thing that's going to help us find a pattern is to make a table. I've just made a table saying the figure number and then the number of squares. If you think back to independent and dependent variables, your independent variable would be your your figure number, and your dependent variable would be the number of squares in that shape. If you look, we go 1 to 5, 2 to 9, and figure 3 has 13. We need to find something that we can do to x, or the figure number, to get y, or the number of squares. Look at your first set. Your first input is 1, and your output is 5. What can you do to 1 to get 5? Well, the first thing that you might think of is you could multiply it by 5. So 1 times 5 is 5. That's what you got for y, so that must be it. Whatever you find or whatever equation you write, it has to work for 1 and 5, 2 and 9, and 3 and 13. So if you go down to 2 and you multiply 2 times 5, you get 10. Which is not what I needed. I needed to get 9. So multiplying by 5 is not a choice. Well, now you might think, well, I can add 4. 1 plus 4 is 5. Again, it can't just work for one of them. It has to work for all of them. So what is 2 plus 4? 2 plus 4 is 6. I'm still looking to get 9, so 6 doesn't work. Now, if you look at the figures above, notice in figure 1, there's 5, and in figure 2, we've added 4 more. So we are adding 4 each time, but it's not consistent. It doesn't just work to add 4. I probably am going to have to multiply x by something and then probably add x, or add something to x. These figures are kind of nice to look at because notice that in each one, there's 1 square in the center, and then in figure 1, there's a square in the center and then 4 more that are forming the plus sign. Figure 2, there's a square in the center and then there's 2 more on each side of that square forming a plus sign. And then on figure 3, you have 1 in the center and 3 more on each side forming the plus sign. Looking at that pattern, and just trial and error type things, we should get to a point where we can say that y is going to equal 4x plus 1. So go back to these ordered pairs up above. We have x is 1, y is 5. We'll plug in 1 for x in 4x plus 1. 4 times 1 is 4 plus 1 is 5. That's what we needed to happen. Now plug in 2. 4 times 2 is 8, plus 1 is 9. Again, that's what we needed to happen. Test it with 3 just to make sure. 4 times 3 is 12, plus 1 is 13. So I do know that to find the number of squares in a figure, as long as I know the figure number, I can say that y equals 4x plus 1. A function is a relationship that pairs each input value with one output value. A linear function has a graph that is a non-vertical line or part of a non-vertical line. So we're going to start talking about functions, and in particular linear functions. Non-vertical means that it is not a straight up and down line. So a linear function has a graph that is a non-vertical line or part of a non-vertical line. The table shows the amount of water, Y, in a tank after X minutes of being drained. Is the relationship a function? Describe the relationship using words and an equation. If you notice, we have time X and water Y. For each X value, remember X's are usually our inputs. So for each X value, I have a different Y value. So for X, I have the value 440, or for X equals 0, I have 440. For X equals 1, I have 428. For X equals 2, I have 416. For X equals 3, I have 404. So for every X value, I have one Y value. That is good. Now, they ask me, so I can say that this relationship is a function, okay? It asks me to describe the relationship using words and write an equation. Using words, notice as my X value goes from 0 to 1, 1 to 2, 2 to 3. So as my X value is increasing by 1, my Y value is decreasing by 12. 440 minus 12 is 428. 428 minus 12 is 416. 416 minus 12 is 404. And while that's happening, like I said, I'm adding 1 to each X value. So describing this relationship using words, I can say as X is increasing by 1, Y is decreasing by 12. You could also say Y is 440 minus 12 times the number of minutes. So 440 minus 12 times 0 is 440 minus 0, which is 440. 440 minus 12 times 1 is 440 minus 12, which is 428. 440 minus 12 times 2 is 440 minus 24, which is 416. So this works. And writing it as an equation, I can write Y equals 440 minus 12 times X, where X is the number of minutes and Y is the gallons, the water in gallons. Today's assignment is on page 258. It's numbers 1 through 16 all.